All right, so the last section in Unit 10, we're going to use problem solving with quadratic equations. And we're going to take what you learned and apply it to a real-life situation. Quadratics are used quite often in the real world. I'm going to try to make them as simple as possible for you as far as your understanding of parabolas. So for instance, the best example that I can give you is throwing something in the air. For instance, let's say that you're throwing a football or a baseball or a tennis ball from one person to another. It looks like when you throw that ball, it goes in a straight line. Especially if you look at the baseball players, when they throw the baseball, it looks like it goes in a straight line, right? But the further away that people become, what does that line look like? It's no longer a straight line. What is it? It's a curve. It goes up and it comes down. Now, it might be a really shallow curve, but what is causing that ball to come back down when you throw it up? Gravity. So whether it's throwing a ball in the air or shooting a rocket off in the air or whatever it is, if there's a projectile that's being moved via some force, it is going to go in a parabolic curve or a quadratic curve. And so we're just going to look at simple examples. You might have to enlist the use of a calculator in some instances, and only one instance today. And then on your homework, I'll look at it and double check, but I'm pretty sure in your homework you won't need it. Shouldn't need a calculator for your homework, but I'll help you with one thing today. Because it's really hard to give these problems and not allow you the use of a calculator. And you'll see why in a minute. Yes. It quite possibly is. What are you learning in physics right now?
Well, no, I think I learned something similar to this at the beginning.
Might have. And you weren't prepared for it. Were you? That's why it probably was very difficult.
No, actually, it got me that
Hopefully we had use of a calculator, right? Maybe you didn't understand wholly everything that was going on. All right, so look at this. You've got the height of a ball above the ground after it is thrown upwards at 40 feet per second. So that's the force that is applied. That's the velocity that that ball is initially going. Now, if the ball is initially going 40 feet per second, is it always going 40 feet per second? No. It's going to speed up and then slow down because gravity's going to slow it down, won't it? Right? Okay. So we've got an initial velocity of 40 feet per second. You don't have to come up with the equation yourself. So they're going to take that 40 feet, and you can see it in the equation that you're given right here. Do you see the 40 feet here? This negative 16t squared is the effect of gravity on that initial velocity. And this is the effect of gravity when our measurements are in feet per second. If I were giving you meters, then you're going to see a different number other than 16 there. It's going to be a decimal. And so for right now, because we don't want to deal with a decimal, we're going to use things in feet per second. And then it goes on to say where the height, h of t, so it's in function notation, right? H of t could be replaced with y or f of x or whatever it might be. But it's your y value. And it's given in feet, and the time t, so what does t represent? If if h of t is y, what does t represent? X. But oftentimes in these types of problems, you're going to see x being t because x is time. And t is a nice number to remind you that, oh, we're speaking of time. At what time in its flight is the ball within 15 feet of the ground? So we're going to go ahead and draw a picture down here. So as I'm throwing a ball, so this is the ground. That's a nice little baseball. It's an excellent picture. So as I'm throwing the baseball, we're going to assume, for your purposes, I'm not going to make it too difficult, that you're actually throwing from his feet. Your hands are like 3 feet off the ground, aren't they? So technically, you're not really throwing the ball starting from height 0, but we're going to assume that it is. When you get into geometry and algebra 3-4, then we can assume that it's a different height off the ground. But for your purposes, we're going to assume it's coming from the toes. and I throw this ball up, it's going to make a parabolic arch through the air, and it's eventually going to hit back down there on the ground. So this ball is going to go up in the air. It's going to reach, wouldn't that be the maximum height? And it's going to come back down eventually. And it's eventually going to hit the ground. So at some point, it's 15 feet off the ground at some point. And that point would represent perhaps here. This would represent 15 feet. Wouldn't ground here be 0 feet? How many times does the ball hit that 15 feet? Yeah, it goes once up, then it goes higher, 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 lower, 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 and it hits it again on the second time going down. Bless you. So that ball is always going to hit a double height, in other words, that height twice, with the exception of one time. What's the one time that won't have a double time? At the vertex, which is that maximum point here, right? This is the only time it's going to have one time. It'll be a double root. So if you end up with a double root and only one time out of your two answers, then you know you've actually found the vertex or that maximum height. And then what would be the height here? 0. So the ball does, at 0 seconds, the ball is going to be 0 feet off the ground, correct? So at a height of 0, one of your answers should be 0 seconds for the time. And then it's going to go up in the air and spend a certain amount of time before it comes back down again. So it might be 0 seconds here and, I don't know, 20 seconds over here. We'll figure out what it is in a minute. But there is such a thing as 0 time because it's your starting time. So the first question is, at what time is the ball here at 15 feet? So we're going to end up finding 2 times. And then another question says, how long does it take the ball to hit the ground? Wouldn't that be the time from here to here? So I don't want the 0 seconds, I want the second one. So we'll find out what that is. And then the third question says, what is the maximum height that the ball reaches and how long will it take to get there? Aren't I asking for the ordered pair for the vertex? The time that it takes to get there is t. So on your ordered pair, normally we have an x and a y value, right? But in our purposes, we're saying that x is t and y is h of t. Meaning that x is time and y is height. So if I ask you at what time does it reach its maximum height, I'm asking you for the vertex. And once I find the vertex, I will have answered both of those questions. And TJ, I need to see your face, not the back of your head. All right, so the first question here asks, or that we're going to find the time when the ball is within 15 feet of the ground. So the 15 feet represents what information? Is that time or is it height? Time or height? So this is height. So we're going to take this original formula here that we've highlighted, and we've got h of t equals 40t minus 16t squared. And we are going to replace all of h of t here. We're going to replace that whole thing with the height that I want to find it at, 15 feet. So instead of replacing it with 0 as we have in the past, we're changing it up a little bit. I can change that height however I want to. So I want to know when is the height, what time is the height 15? So I have 40t minus 16t squared. So now take the picture out of it and take the story out of it and just look at the quadratic equation. Use your algebra. What are you going to do first? Say it really loudly. Well, I need
0.
That's right. I need one side equal to 0. So I could move the 15 over, but I really don't like working with a negative t squared, personally. So I'm going to actually move everything over to the left side. So I'm going to add a 16t squared. I'm going to add a 16t squared, and I'm going to subtract a 40t. We're going to do it all at once and subtract a 40t. So these cancel on the right. I'm going to zoom in on that for you. So then I'm going to write these in descending order. So the t squared comes first. So I have 16t squared plus the minus the 40t, and plus 15. Now that equals 0. So now I'm going to find A equals, B equals, and C equals. So what's A here? 16. B equals negative 40. And C is equal to 15. Now, we have choices. We could complete the square. Do you want to complete the square with this one? No, why? This is divisible by 2, but there's a 16 there. Is there a greatest common factor for all three of these?
No.
So I can't get rid of that 16, unfortunately. So, and I just want you to notice that C in this case is 15. Isn't that the height we're trying to find, our y-intercept of 15, so to speak, in this case? So it's interesting that you'll see that 15 there. So I don't want to complete the square. I don't want to graph it, because that's kind of ugly to graph, isn't it? How about factoring? Do I want to factor? There's no GCF to lessen my number. So I'd have to do 16, TJ. Put it in your backpack. I don't want to see it again. The next time you go to the office with a referral, how about that? 16 times 15, and in fact I believe I'll email Mama. Let her know that that's becoming an issue for you. 16 times 15 is a big number. Do you want to factor that and do group and garbage? I don't want to. So what method is left? The quadratic formula. So that's what we're going to use. So you're probably going to want to go down this way. The quadratic formula, so t equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Did you learn that this weekend? Hopefully you did, because you have a quiz coming up this week, sometime could be today. So my b is negative 40, so it goes here, and also here. My a is 16, it goes here, and here. And then my c is 15, and it goes here. Yes?
If,
You okay?
yeah,
Okay.
I can see the screen.
So then the opposite of negative 40 is 40, plus or minus the square root of, we're going to save a little space here, negative 40 squared. What's 4 times 4? 16, and what's 0 squared? Double zeros, right? And then negative squares out to a positive. And I just have one negative here. And if you take 4 times 16 times 15, you actually end up with 960. And then if you subtract those two, we end up with 640. I'm going to take away that long line that I just drew there. All right, so all over 32. Now, this is where 640 is not a perfect square. So you could simplify this, and that would be your answer, but this is a word problem. Do I really want my answer to look like this? So in real life, wouldn't we crack out the calculator? We are. So you could either estimate this by using a perfect square below and above, but the problem is you're going to have some trouble dividing by 32. So I'm just going to help you out. That the square root of 640, if you plug it into your calculator, turns out to be 25.3. All divided by 32. So then I need to come up with two different answers. One answer is going to be at the first time that the ball hits 15 feet, and the second answer is going to be the second time. So the shorter of my two answers will be the first 15 feet, and the longer of the two will be my second. So if I take 40 and add 25.3, I end up with 65.3, and I'll divide that by 32 in a minute. And if I take 40 and subtract 25.3, I end up with 14.7 divided by 32. So my two answers turn out to be I get two approximately, so I'll make those squiggles, 2.04 and 0.46. If I actually divide those out with a calculator. So let's answer the question. Find the time when the ball is within 15 feet of the ground. So therefore, the ball will be at 15 feet at about 0.46 seconds and 2.04 seconds. So you can go and tag on your picture the seconds. So over here, the first 15 here, this would be 0.46, comma 15. Wouldn't that ordered pair be that? And what's this ordered pair going to be? Yeah, this ordered pair will be 2.04 seconds, 15 feet. For this one right here. So that one did require use of the calculator. The rest of them won't. So then the next question that they asked, or one of the other questions, was find the time it will take for the ball to hit the ground. So I've got that on C there. So I want to find the time here and here. What's the height at that time or that place? Question? I just kind of estimated on my picture. Because it's your drawing, you can make, I figured he's about maybe 6 feet tall, let's just say. So I obviously want to choose something higher than a person, right? So my picture isn't necessarily accurate. Say that again. I know he threw it higher than 15 feet because I got 2 answers. Does that make sense? If I'd gotten 1 answer, then I would know that that would have to be my maximum height. So I know that somewhere in between 15 and, somewhere up there is a maximum height. So if I keep going up here and kind of guessing and checking with heights, then I might eventually figure out where it might be. Because what's going to happen is, let's say I choose a height of 50, and I plug 50 into my quadratic formula, at some point it's not going to work. So, but you won't have to do that. I'll just ask you, what's the time at this height or at this height? So C is kind of a little bit more vague because it's saying what's the time it will take for the ball to hit the ground. You have to make the connection that the height is what? What's the height of the ground? So the height of the ground equals 0 feet. You have to make that connection. I won't tell you that. So you're like, oh, okay, height is 0. So instead of h of t, I'm going to put 0 in place of h of t. And the rest of that formula that I gave you originally would be 40t minus 16t squared. Take the story out of it. What are you going to do to solve? Yeah, there is a GCF, right? So factoring in this case would be good. I mean, you could still use a quadratic formula. I wouldn't complete the square, mostly because it's going to be ugly. But I would definitely factor, because this is an easy factoring one. I only have to use group and garbage. It has a GCF of what between 40 and 16? 8, right?
8.
8 goes into 16 and 8 goes into 40. So I've got 0 equals 8, and then they have a t in common, right? So that comes out in front. What is 40 divided by 8? 5, and then the t divided by t goes away. Negative 16 divided by 8, negative 2, t squared divided by t is t. Then what do? If this times this equals 0, doesn't either that or that equal 0?
Yeah.
So you're going to set 8t equal to 0, and you're going to set 5 minus 2t equal to 0. So you're going to have to squeeze in our work a little bit here. So if I divide by 8, what does t equal? And didn't we anticipate earlier that we would have 0 seconds at a height of 0? Because that's our starting height, and our starting time would be 0, 0. 0 seconds, 0 height. And then he throws the ball, it goes up, 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 and it comes back down to here, and we're going to solve this. So if I subtract 5 from both sides, what do I have? And then if I divide by negative 2, t is equal to a positive 5 halves, and we're not going to walk around saying, I'll see you in 5 halves seconds. You look like a dork, right? So what are you going to actually say? 2.5 seconds. So therefore, so up here in this free space, therefore answer the question. We don't want time t equals 0 seconds. That's not really what they're asking for, is it? They're asking, find the time it will take for the ball to hit the ground. Well, the ball started here at the ground. That's not when it hit it. He threw it from here, then it went all the way up and down to here. So we're really only looking for the 2.5 seconds. So therefore, it took the ball 2.5 seconds to hit the ground. Okay. And then the last question says find the maximum height that the ball reaches, and you need to label this height. So this height, maximum height, would be right here. So we're going to label that point. We're going to come up with an ordered pair. So that point's the vertex. How do you find the vertex with a quadratic formula or quadratic equation? So x, or in our case t, right? So you might want to put on here, you need to find the vertex. And that's using, in our case, we'll say t equals, instead of x equals, the opposite of b over 2a. So looking at the original equation, we have h of t is equal to 40t minus 16t squared. What's b? B is what? Be really careful. Remember, b is the you have to be careful on this one. B is the coefficient of the non-squared term. So in this case, the t term. So b is 40. They're out of order, right? And so that means that a is what? The negative 16. So make sure you get that sign in there that it's negative. And so the x value of the vertex is equal to the opposite of b over 2a. So I'm going to put in here b is 40 and a is negative 16. Won't the negatives cancel out? Right? Can't I cancel this 2 into the 40 20 times? So I have a positive 20 over a positive 16, which still reduces. What goes into both 20 and 16? 4. So I have 5 over 4. And mind you, x is that height or is that time? That's time. So this is equals to 1 1/4 seconds. Is that what they're looking for? No. We want the maximum height. So then I need to plug in, and I'm not going to use 1 1/4 when I plug in because that's not very useful. I'm going to use the improper form. So I'm going to find the y value of the vertex. I'm going to plug it into the original equation, which is over here. So 40, I'm going to put 40 over 1, only because t is a fraction. So I'm going to put this 5/4 in place of t, so 40 times 5/4, bless you, minus, I'm also putting the 16 over 1, but I'm going to multiply it, I'm going to use substitution parentheses because don't I have to square t first, and t again is 5/4. Well, here's the nice thing about this particular problem. What does the 4 and the 40 do? They cancel. So 4 cancels into 4 once and into 40 10 times. So I end up with 10 times 5 is 50 minus, I can't multiply the 16 yet, so I've got 16 over 1 times, what's 5/4 squared? 25 over 16, which is nice. Why? The 16s cancel 1 for 1. So really what I'm looking at is 50 minus 25, which is what? 25 what? Feet. That's what they're looking for, right? So off to the side here, we're going to put, therefore, the maximum height is 25 feet. But then this part right here says how long will it take to reach that maximum height? Haven't we already found that? So can't we take our knowledge of this and bring it down here and just answer that question? Therefore, it will take 1 1/4 seconds to reach the maximum height of 25 feet. And last but not least, we still have to label that on our picture. So we're going to come up here and label this on our picture that this is my maximum height of 1 1/4, that's our time, and 25 feet. So there's a lot that goes on with one problem, and you're only going to have 3, maybe 4 problems tonight, because it takes a while to do, right? All right, so I'm going to give you your homework, and we're going to work on it. I'll come around and help.